This video is on application involving average cost, average revenue, and average profit. So before we do the application problem associated with this, let's talk about what it means to have the average cost, average revenue, and average profit. So just as a small definition to start, if C of X is the cost to produce X items, right? So it's a cost function, C of X, and we've seen that before. The average cost is C of X, the cost function, divided by X, the number of items you produced. Which kind of makes sense, right? When you take the average of something, usually you take whatever the total is and you divide by the number of things you're taking the average of. That's all we're doing here, right? The cost function is C of X, that's the cost function, that's the total, divided by the number of items that we produce will give you the average cost, right? In a similar way, I'm not going to write it out all formally. Similarly, though, right, average revenue would be the revenue function, R of X over X, and average profit, you probably could guess, is P of X over X. So, the key here is that, when you hear these words, average cost, average revenue, average profit, you need to know that you're really taking whatever that function is, cost, revenue, profit, and dividing by the number of items, dividing by the variable we're talking about, which is X in these cases. So average cost, average revenue, and average profit all have the form of that function divided by the number of items, X. All right, so divided by the variable. So now we're ready to really talk about an example using this. This example here is similar to one that you might find in your homework, but it's helpful to look at it. It might be a little lengthy in terms of what's used in it, but it's really just following along based on what we just said. So a greenhouse finds the cost in dollars of growing X flowers is given by. So they're going to give you a function here, and the cost function, C of X, is equal to 200 plus 100 times the fourth root of X, right? So that's the cost function. They're giving us this. And revenue from selling X flowers is given by R of X for the revenue function. R of X equals 120 plus 90 square root X. And what they're going to ask us to find is a few different things. All right, so the first thing, find the average cost, average revenue, and average profit functions from selling X flowers. So they're asking us, based on these cost and revenue functions, to find the average cost function, the average revenue, and the average profit functions. It's not overly complicated. We just talked about it a minute ago in our definitions, how to find these, right? So it's really the function they give you divided by the number of items you sell or produce, depending on the way you're looking at it. So for my solution for part A, right, let's just talk about what happens here. The average cost, which I'm going to use A with a little subscript C here for average cost. Maybe I'll call it average cost of X, just so we know how we're describing it. So this is the average cost function, and it's equal to, what would we say? It was the cost function C of X over X, the number of items that you produced. So now I'm just substituting in with what the cost function is here, right? So if I said the average cost function of X, I'm really just going to say this is 200 plus 100 fourth root of X all over X. So that's the average cost function. Average revenue, maybe I'll call that one. So here's average cost. So that's the first one. For average revenue, I'll call this A sub R of X, just so you know it's a different function. So average revenue, it's equal to, remember what it was, it's R of X over X. Well, we know what R of X is, right? We have it, it's 120 plus 90 square root of X all over X. So that's the average revenue function. Remember, this is just the name I gave it. You could have called it anything you wanted, but don't call it one of the functions you already know you need to use. You can't call it C of X, R of X, or P of X. And then the last one we got to find is average profit. Now, we said above that the average profit is P of X, the profit function over X, but they didn't give us P of X. So the first thing you got to do is make sure that you find what the profit function is, and then find the average profit. So to find P of X, if you remember how you find P of X, profit is equal to the revenue minus the cost. So it's really going to be the revenue minus the cost, and then that whole thing over X. So I'll do that on the next page, just so we have more space to work with. But if I was looking at this, and I'll call this average profit. So I'll write it as, A sub P of X. It's equal to the profit, P of X, over X. And we know to get profit, we just said it a second ago, it's the revenue minus the cost. So revenue function minus the cost function over X. And what's that equal? Well, that was the revenue function, which was the 120 plus 90 square root of X minus the cost function. Make sure you put parentheses around it. It's minus the entire cost function, C of X. C of X was the 200 plus 100 fourth root of X. So 200 plus 100 fourth root of X all over X, because we want the average profit, right? So that's the profit function in the numerator. The average profit is that over X. Let's simplify this so it's easier to work with. So the average profit of X is equal to, simplifying this, we'll bring this negative sign through. 120, right, minus the 200 will give me a negative 80 to start. This negative gets distributed through, but doesn't combine with that. So we got plus 90 square root X minus 100 fourth root of X all over X. Now, I kind of skipped a step in here, but I think you can see what I did, right? I distributed the negative in here, and then I combined the like term with the 120. Just to make it easier to work with, so I don't have to distribute and then combine. So I distributed that, I noticed it combined, and I added them together. So I got negative 80 plus 90 square root of x minus 100 fourth root of x all over x. So we found what they asked us to find. The average over here, the average cost, the average revenue, and the average profit. Now they may ask you follow-up questions to this, so let's ask one just to make sure we understand what's going on. If I said for part B, find the rate, it's important, that word rate, find the rate at which the average profit is changing when 200 flowers are sold. So a couple things. When you hear rate, right, at a specific value, that should make you think, okay, I'm looking for the derivative. What function am I looking at the derivative from? I'm looking for the derivative of the average profit, right? So the rate at which the average profit is changing. So this first part is telling you to find, remember, rate of change at an instant, that's the derivative. So I'm really looking for a prime, right? A sub p prime of x, right? The derivative. And then I will sub in 200 flowers. So this is actually saying find a sub p prime of 200. But first you got to find the function. Then you sub the 200 in. You can't sub the 200 in first because then you actually just have a constant. And then the derivative will always be 0. So you always want to take the derivative first of the function and then substitute in the value when you're asking to find the rate of change at a specific point, right? Derivatives are the instantaneous rate of change. So we're going to use, right, this AP of x, right? That's the original function. And we're going to use it to find the derivative. Now, if I'm going to use this function to find the derivative, the first thing I should notice is that it's not really in a nice form to work with. In other words, you know, you've got these roots in here. So let's simplify this. So, you know, this is going to be a rewrite. Remember, you need to rewrite this if you have any radicals in there, any x's and denominators in terms of a term. So I'm going to rewrite this. This is still the average profit function, AP of x, and it's equal to negative 80 plus, this is 90. Now, instead of square root of x, I'm going to write that as x to a power. Remember, square root is x to the first, right, on the inside, and the index is 2, so it's 1 over 2 is how you rewrite it, minus 100. Fourth root, we want to write as x to the power on the x is 1 over the index, which is 4. And this whole thing is all over x. And you could do this in one of two ways. I'm going to probably do it in the more complicated way because I want to show you an application using quotient rule. So I'm going to use the quotient rule here. It also will make it easier to, it'll be more challenging probably to get the derivative, but it'll easier to evaluate what we need later. So now we're ready to take the derivative. So a sub p prime of x is the derivative. And because I have a function divided by a function, I'm using the quotient rule. The quotient rule says take the derivative of the numerator, take the derivative of the top. So derivative of negative 80 equals to 0. Derivative of 90x to the 1/2. Bring the 1/2 down becomes 45x to the negative 1/2, subtracting 1 from the exponent, minus 100x to the 1/4. We bring the 1/4 down times 100, so we minus 25x to the subtract 1 will be negative 3/4. That's the derivative of the numerator, times you multiply it by the denominator. All right, and then minus, you want the derivative of the denominator, right? Derivative of the bottom, which derivative of x is just 1, times, you keep the numerator, so negative 80 plus 90x to the 1/2 minus 100x to the 1/4. And this is all over, remember for quotient rule, it's all over the bottom squared of the denominator squared, in this case, x squared. We should simplify this. So now we're working with the derivative. So this is the unsimplified form, right? But you still have the derivative now in front of you. To simplify this, I'll distribute through, and then we'll combine like terms. So 45x to the negative 1/2 times x will make this 45x to the, remember you add the exponent, so negative 1/2 plus 1 is a positive 1/2 power. X times the negative 25x to the negative 3/4 will be negative 25x to the positive 1/4 power, because negative 3/4 plus 1 gives you positive 1/4. Here we're distribute the negative 1 through, so it's going to change the signs on these terms. So negative 1 times negative 80 would be a positive 80. Negative 1 times a positive 90 makes us a negative 90x to the 1/2. Negative times a negative makes us a positive 100x to the 1/4. It's still all over x squared. And then, we want to combine like terms here to make this easier to work with. So I've got that a sub p prime of x, right, this derivative, is equal to 45x to the 1/2 minus 90x to the 1/2 is a negative 45x to the 1/2. Negative 25x to the 1/4 plus 100x to the 1/4 will be plus 75x to the 1/4. And then we have plus 80. It's all over x squared. Alright, so a lot of work involved in the simplification. If you had rewritten this in a different form where you divide each term by the x, you might have had an easier time working with it. It's equivalent. Comes out the same. Now, what were we trying to find though? We want to find the average profit, right, the rate at which the average profit is changing when 200 flowers are sold. This is telling us we want the derivative when x equals 200. We found the derivative, now we're ready to sub in the 200. Because remember, the derivative gives you the rate of change at any value for x. We're looking for it at a specific point when x is equal to 200. So when we do this, we want a prime of p of 200. And we're going to substitute it in. And, we'll use our calculators to help us here. So you'll end up with this negative 45 x to the 1/2. Well, x is 200 to the 1/2 plus 75 times 200 to the 1/4 plus 80 all over, this is going to be 200 squared. And you can approximate this on your calculator. You could also, knowing this is 1/2 is the square root, 1/4 is the fourth root, you could also evaluate it that way. If we type it in, just be careful with how you're writing it. I will write it in here, see if you can see what I'm typing in. So if I put negative 45, parentheses around the whole numerator, right? So parentheses, and then put negative 45 times, this will be the square root of 200. It's the same as saying 200 to the 1/2 power. I'm just writing it as square root because it's easier to work with. Plus 75 times, now this is the fourth root. To do the fourth root on this calculator, you might see it here, it's the second key on this caret, so you want to put 4 and then hit the second key, so it's the fourth root of the value 200. Alright, and then plus, after that, 80, close the parentheses, and then we want to divide the whole thing by 200 squared and put that in parentheses as well. So we get this negative 0.006858, it continues on. So, and it's a very small number, it's a negative number, that's important, but we'll put the approximation here next to what we got, and the approximation for this, we have negative 0.00, and I'll just round it to that thousandths place. So the 8 rounds a 6 up to a 7, so negative 0.007. What are the units? Well, let's think about it. So we got negative 0.007 is our approximation. The units on this, right, think about it as, change in y over change in x. The average profit, right, was our function. That was the original function. Average profit was measured in dollars. So when we talk about this a prime, right, or AP prime, I should say, right, the average profit prime would be the units of y, whatever the units of the original function came out to, so it would be dollars, per change in whatever the X is measuring. What's X? Well, X is the number of items, in this case flowers, so it's dollars per flower. So, okay, I found that, right? That's the rate. But let's talk about what it means practically, right? Because this is really, where it's going to help us. So when we look at this, the rate itself tells us that, first off, negative $0.007 sounds weird to say, right? And we'll talk about what that really means in terms of cents in a minute. But really this is telling us at the instant when 200 flowers are sold, right? That's what happens when we subbed into this, right? This is when 200 flowers are sold. The rate of change will change if it was 201 flowers. So when 200 flowers are sold, the average profit, remember we're trying to find the average profit, the rate of change of that. Well, the average profit, how does it change? It's negative, right? So the rate's negative, so the average profit is decreasing, so it decreases at a rate of, well, this is $0.007 per flower. You could write it that way. But how would you talk about cents? Well, when you talk about cents, right, to move from dollars to cents, you would move the decimal 2 to the right, right? Kind of how if you had 25 cents, you could write it as $0.25, or you move it over 2 to the right and say 25 cents. Same thing here, just looks weird with a decimal. You move it over 2, you get 0.7 cents. So at a rate of 0.7 cents per flower. And that would be a sentence summarizing what we just found. Keeping in mind that 0.7 cents might sound like a nothing number, right? Because 1 cent is the smallest amount you could physically have. But remember, over time in a business, these 0.7 cents would add up to value in dollars, right? So it's not unreasonable to talk about it that way. It just means it goes up by a fraction of a cent per flower sold. Or actually, in this case, it declines, right? So it decreases by a fraction of a cent per flower sold. So hopefully this example helped. Make sure you understand, when you see average cost, average revenue, average profit, it means take whatever function they're talking about and divide it by X, the number of items you have. From there, they might ask you questions about how the rate of that is changing. When you take the rate of that, you'll have a fraction. So a lot of times, you have a function divided by a function where you could use quotient rule like we did, or you could simplify it in a different way, depending on how you wanted to differentiate.